Okay, some of this will be a review, and most of it you should have seen in that assignment that we did out of the book, but some of it will be brand new for you. So, definition of a wave is a wiggle in time and space. Okay, so it's different than simple harmonic motion because you're going to have the back and forth movement up and down, but then you also have it moving in time. Okay, so the back and forth movement up and down is just simple harmonic motion. When you add in time to it, that's when you make it a wave. Things that are wave are sound, light. Radio waves are a special type of light wave. Water. Many things that we deal with on a regular basis actually are waves. So parts of the waves, the high points are crest. The low points are troughs. The amplitude is the height from equilibrium, which is going to be just the center place of the wave. So the distance between the equilibrium point and either a crest or a trough, because this distance here would also be an amplitude. And then there is a wavelength. Wavelength is the distance from one point on a wave to the same point on the next wave. So examples of that, really easy ones to pick out if you're literally having to measure a wavelength. Measure from a crest to a crest or a trough to a trough. But say we started like right here. In order to get the right wavelength, you must include an entire up and down motion. So you go to the same point on the wave as where you started. So this distance here looks the same as those other lines because that is also a wavelength. Okay, or you could do something like this. Okay, if we start there, you need to go through the down and the whole up motion. All right, and then it would actually have to continue down to here. So that would be another wavelength. Okay. Some other terms, and we've dealt with some of these already. Period is the time it takes to go one wavelength. All right. So if one wave occurs in 6 seconds, your period is 6 seconds. All right. Frequency is the number of wavelengths in 1 second. Okay. So if say there's 5 waves in 1 second, then your frequency would be 5 hertz, okay? Whereas then it would be 1 wave every like 0.2 seconds, all right, for your period. So remember, frequency is measured in hertz, and again, we'll still be working with these relationships of frequency and period being inverse to each other. So you can always, if you know one, you could do 1 over that to figure out the other. So waves transfer energy. Okay, they don't transfer actual objects. They're going to move through whatever objects are in the area. Okay, transferring the wave, but not the actual things. So like, think about sound. When someone's talking, like when, if you're listening to me say this right now, is there like wind blowing in your ear because I'm making sound waves? You should hopefully be saying no. Okay? So what's happening is the sound is transferring through the molecules in the air. Okay? Through the molecules without actually moving the molecules. Okay? So energy is transferred, matter is not. Which is also the whole reason why a string phone works, because even though the string doesn't move, the sound can still get through. All right? The energy or the wave is created by a vibrating source, the thing that's going back and forth. All right? So every wavelength is a, or one, vibration. Waves also have velocity. They can move very quickly, they can move very slowly. All right? It depends on what they're going through. So, for example, in air, waves move pretty quickly. But in water, they actually can move even faster, which is why something like sonar for submarines works. Okay? So the speed of sound in air is 340 meters per second. In water, it's closer to like 1,300 meters per second. Okay? So there's a relationship between velocity, or the speed of a wave, its frequency, and its wavelength. And that relationship looks like this. Velocity is represented by the v, frequency is represented by f, and then this funny Greek letter, it's called lambda, that is what represents wavelength. So if you ever had to solve for any of the other variables, like say you wanted to know what frequency is equal to, so we'd have to get rid of lambda, cancel that out, that would be velocity divided by lambda, all right, or wavelength. Say we wanted to know what the wavelength was and we knew velocity and speed. That would look a little different. We would have to divide by frequency to get lambda by itself. So lambda is equal to velocity divided by frequency. Okay? So, and this was that activity you were supposed to draw and do by hand in the book. For a given frequency, okay? So say you make 1 wave per second. All right? So 1 wave per second. What happens is your wavelength is going to change size. So let's say that, all right, if this is 0 time, this is going to be 1 second, that's going to be 2 seconds. Your wavelength is from here to here. All right, so let's say again, down here, if it's a large velocity, our frequency is still 1 wave per second. So this will be 0. 1 wave means 1 second has passed. 2 waves means 2 seconds have passed. Except now, your wavelength is this long. It's much longer. Okay? So the faster the wave moves, the more the wave is spread out, which means the longer the wavelength. All right? I know that was counterintuitive to what some of you guys thought was supposed to happen. So if you have a wave that's being drawn, so say you have this frequency and then you just kind of keep that frequency going but move it slowly, you get lots and lots of waves in. Whereas if you do the same thing, got the same frequency kind of going up and down, but now I'm going to move faster. Now the waves are spread out more and you have a longer wavelength. Okay? So, some problems that you might have is something like this. This starts out with a really easy one because this is just plug and chug. So, what is the velocity of a wave that has a wavelength of 2 meters and a frequency of 0.2 hertz? So, we know lambda is 2 meters. We know frequency is 0.2 hertz. We know that velocity equals 2 meters equals frequency times lambda, so that's going to be 0.2 times 2, which is equal to 0.4, and then your units, remember, you're having a meter times a hertz. But remember, hertz is also a 1 over a second, so meter times 1 over seconds. That actually gives you meters per second, okay? Which is what we know to be the units for velocity. Something that might be a little bit more complicated is what is the velocity of a wave with a wavelength of 3 meters and completes 5 wavelengths every second, okay? So we have 5 waves per 1 second. That is equal to 5 hertz, which would be our frequency. Okay, because it's telling you how many waves are happening per second. That is frequency. And then wavelength is given to us directly. So again, velocity equals frequency times wavelength. So velocity equals 3 times 5. And velocity equals 15 meters per second, right? One last thing, and I put the last problem on here again. So this one we've already done, but notice how it says completes Actually, sorry, I wanted that to be the last one. So 5 waves per second. So pretend that actually did match the last line. Notice the difference. What I wanted you to zone in on is the difference between these two statements. So we have a velocity of a wave that has a wavelength of 3 meters, and it completes 5 waves per second. 5 waves, so that's going to be 5 over 1 second, which is 5 hertz. Okay? This problem is saying 1 wavelength in 5 seconds. So that's going to be 1 over 5 seconds, which is equal to 0.2 hertz. All right. Remember, whenever you're trying to find frequency, you take the number of waves and divide it by the time it took. So just be careful with those sorts of things, because you should always end up with the seconds on the bottom if you are solving for frequency. All right. Bottom. So we know our lambda 3 meters. We know so if we're actually solving the second one, frequency is 0.2 hertz. We know velocity is equal to frequency times lambda. So that's going to be 3 times 0.2, which is going to be 0.6 meters per second. So you have to pay close attention to the way the words are phrased, okay? If it's multiple waves in 1 second, then your frequency is going to be greater than 1. If it's 1 wave in many seconds, then your frequency will be less than 1, okay?